Okay, so I'm going to quickly go over the logistical growth model. This is super easy equation to use. Again, we're going to use the calculator for a lot of this problem. So make sure you've got your calculator and you know how to use it. So basically, you're going to be given this equation with the population P after time T obeys the equation, and here's our equation, and notice we have a couple of variables. A, B, and C are going to be constant. B and C will both be greater than 0. So the P is going to be the population. C, if we go back up here, it's the carrying capacity. So it's the maximum amount that a situation can support. So this is the most of something that can be in the situation. And then A and B down here are just going to be two other constants that we will have or have to find, and T will be time. Let's work through our first problem. It says that 6 American bald eagles are captured, transported to Montana, and set free. Based on previous experience, the scientists expect the population, P of T, to grow according to this model. P of T equals 500 divided by 1 plus 83.33 e to the negative 0.162 t for t years after the introduction. Okay, so we're looking at years. So this equation means that this 500 at the top, that is our carrying capacity. So the scientists believe that there will only, the maximum amount of eagles that could be in Montana would be this top number. That's the maximum eagles. All right, that's the carrying capacity, okay? If we look at our question A, what is the carrying capacity of the environment? That's just going to be 500 eagles. B says, what is the predicted population of the eagles in 20 years? So T is in years, so we're just going to take 20 and plug it in for what variable? We would have our population is going to equal 500 divided by 1 plus 83.33 e to the negative 0.162 times 20. We're just going to put that directly into our calculator. Make sure on the bottom, that whole bottom piece is in parentheses. When we plug it in, we get 117.27. And we're talking about eagles. Can we have 0.27 of an eagle? No, we cannot. So after 20 years, based on that equation, there should be 117 eagles. Okay, C says, when will the population be 300? So the only variables in our equation are P and T. So obviously the 300 isn't time, it's our population. So this time we're going to be solving for time. So we're going to plug in that 300. Let's see if I can keep this. We're going to plug the 300 in for the P of T. So 300 equals 500 divided by 1 plus 83.33 e to the negative 0.162 t. So from here, we've got a little bit of solving to do, just some algebra. Trying to get the t by itself. First, we need to move everything on the bottom. We need to get rid of the bottom. So we're going to multiply both sides by the denominator, which is just going to move this up here. So we're going to have 1 plus 83.33 e to the negative 0.162 t times 300 equals 500. Okay, I'm not going to distribute that inside. I'm just going to go ahead and divide by 300 on both sides. We'll just reduce this fraction to 5/3. So over here we would have 1 plus 83.33 e to the negative 0.162 t equals 5/3. Alright, hopefully we're starting to see we're trying to get this e to the negative 0.162 t by itself because we're trying to get that t exponent rearranged. Because we're going to subtract 1 on both sides. 5/3 minus 1 would be 5/3 minus 3/3. That is 1. 3.33 e to the negative 0.162t equals 2/3. All right, we're going to divide by the 83.33. So really, you could also think of this as multiplying by 1 over 83.33. Because over here, this 2/3, we really just want to multiply this straight across. So e to the negative 0.162t equals 2 times 1 would be 2. And on the bottom, we can just leave this as 3 times 83.33, or you can multiply it in your calculator. Now, we've got bases that are different. We'll take the natural log of both sides. Natural log of e cancels. Negative 0.162t equals 2 divided by, what would this be? 3 times 3 is 9. 9.9. 8 times 3, 24. Try to get t by itself. So again, we're going to divide by that negative 0.162, or you can say multiply by 1 over that. And that's going to be our t value. You can put this into your calculator, and our answer should be 29.8 years. I do apologize for the sound quality. I know it's not the best. I need a microphone, but I don't have one. Okay, so basically that's how you do these problems. You're either taking that number and plugging it in for p, or you're plugging in a number for t time. So if you flip over to the back, notice just one more problem. It gives us this logistical growth model. P of t equals 0.90 divided by 1 plus 3.5 e to the negative 0.339t. Relates the proportion of new personal computers sold at Best Buy that have Intel's latest coprocessor T months after it has been introduced. Computers at Best Buy that have the latest coprocessor. It says what proportion of new personal computers sold at Best Buy will have Intel's latest coprocessor when it's first introduced. All right, so when t equals 0. So we're just taking our original equation, plugging in a 0 for t. 6.9 divided by 1 plus 3.5 e to the negative 0.339 times 0. We know all this is 1. So we're just going to have 0.9 divided by 1 plus 3.5 will be 4.5. That should give us 0.2. So really what's happening in this equation, that 0.9, that's 90%. So 0.2, we could turn it into a percent. So this is going to mean 20% of those new personal computers sold at Best Buy already have that coprocessor. And our growth model saying the most that store is ever going to have, the most would be 90%. All right. And that's me answering the next question. It says determine the maximum proportion of new personal computers sold at Best Buy that will have Intel's latest coprocessor. So again, the 0.90, that's our maximum capacity, but it's not saying that 0.9 of the computers have it. You want to turn that into a percentage. So turn that into a percent, it becomes 90% will have that coprocessor. All right. And then our last problem, similar to the eagle problem we did, we're going to be plugging in something for that P. So it says when will 0.75 or 75% of new personal computers sold at Best Buy have Intel's latest coprocessor? The 0.75 is going to be our P. So 0.75 equals 0.9 divided by 1 plus 3.5 e to the negative 0.339 t. So again, we're solving for t. Really what we can do here is I can just take this 0.75 and switch it with the whole entire bottom. That's what happens here. You're going to really multiply by the bottom and then divide by that 0.75. So if you just switch them in one step, it kind of eliminates some of the writing. So I'm just going to do that. 1 plus 3.5 e to the negative 0.339t equals 9 divided by 0.9 divided by 0.75. You put on the calculator 1.2. How about that step out? So 0.9 divided by 0.75. This is 1.2. Right, then I'm going to subtract 1 on both sides. 3.5 e to the negative 0.339t equals 1.2 minus 1 is just 0.2. Divided by the 3.5. So e to the negative 0.339t equals 0.2 divided by 3.5. Bases are different. I cannot make them the same. Natural log of both sides. Negative 0.339t equals the natural log of 0.2 divided by 3.5. Divide both sides by negative 0.339. T equals, so you're putting into your calculator the natural log of 0.2 divided by 3.5. All of that divided by negative 0.339. We're getting our time. This is talking about months. We would get 8.4 months. So those are that's the process for the logistical growth model. Either just look and see, are you plugging in for T or are you plugging in for P? And then that top number on your fraction will be the carrying capacity or the maximum number of whatever is happening.